What is fire? For centuries, for ages, men have known and used fire and flame without understanding much about them. Even today, the true nature of fire is something of a mystery. A simple wood fire reveals some important facts about burning. Wood contains a large amount of the element carbon. Carbon can burn only when it has plenty of air around it. If the supply of air is cut off, the fire goes out. On the other hand, the more air a fire gets, the hotter the flame. Air contains oxygen. When wood burns, 1 part of carbon combines with 2 parts of oxygen from the air to form a gas called carbon dioxide. In carbon dioxide, carbon has taken on all the oxygen it can use, so carbon dioxide won't burn. Carbon dioxide is much heavier than air. In fact, it can be poured, just like water. Carbon dioxide will put out a fire because it forms a smothering blanket over the flame. This is the basic principle of the modern fire extinguisher. Now let's see what happens when carbon is burned in a limited amount of oxygen. We'll use charcoal, which is almost pure carbon, and cut down the supply of air. Now the carbon takes on less oxygen, only half as much, and forms a gas called carbon monoxide. Because only half the carbon has been used up by the oxygen, carbon monoxide will burn. If carbon monoxide is allowed to escape unburned, half the energy in the carbon is wasted. So the efficiency of a fire can be measured by the amount of energy it wastes in carbon monoxide. The more efficient a fire, the less carbon monoxide it produces. Engineers have developed a precision measuring device to determine the exact amount of carbon monoxide produced in a fire. This device draws in a sample of the gases around the flame, measures the carbon monoxide, and shows the exact amount on an indicator. In this case, the indicator tells us that there is 15% of carbon monoxide being wasted in the burner. Now we'll open the cover and supply a lot more oxygen. The carbon burns completely, and the fire is hotter. When we draw another sample from our testing device, we find that the amount of carbon monoxide has been cut down to as low as 5%. The carbon is combining with all the oxygen it can use. Engineers call this complete combustion. The most efficient fires for industrial purposes are produced by the complete combustion of carbon in some easily handled form, such as coal or coke or gas or oil. Industrial fires must be carefully controlled so that the right amount of carbon is allowed to combine with the right amount of oxygen to avoid waste. The fires which turn crumbling lumps of iron ore into hard, strong steel, the fires which change dull mixtures of sand and lime into beautiful glittering glass, the fires which make steam to drive massive machines, are regulated to supply plenty of oxygen for complete combustion, to get all the carbon energy out of the fuel.